Hello, welcome to Engineer's Mindset. Now I'm going to show you how to differentiate from product rule. Let's say y is a function of u and v. So you have y to be a function of u, v, where u is actually a function of x and v is also a function of x. Okay, now to differentiate y with respect to x, that's the y dx, I'm simply going to, since u is multiplying v, it means I'm going to apply the product rule. And this is the product rule. It simply says keep u constant, so I'll simply have u. Then since v is a function of x, then differentiate v with respect to x. So I'll simply have the v all over the x plus, now you keep v constant, so I'll simply have v. Then simply, since u is a function of x, then differentiate u with respect to x. So I'll simply have the u with respect to the x. So that is the rule. Keep u constant, differentiate v with respect to x, plus keep v constant, differentiate u with respect to x. So this is the product rule. And we're now going to apply this towards solving problems in differentiation. Now let's try the first example and see what we're going to have. Okay. Let's say I have y to be equal to 3x squared plus 2 multiplied by 5x minus 3. Okay, so let's say I have this and I'm asked to find the y, the x. So since I have this bracket multiplying this bracket, it means I'm going to employ the product rule of differentiation. So the first thing I will do is this. I will say let u be equal to 3x squared plus 2. So I'm saying that let the whole of this term be called u, and let v, okay, and v be equal to simply 5x minus 3. So the whole of this term be called v. It automatically now means that this now implies that y itself is now what? In place of 3x squared plus 2, I simply call it u. So it's now u dot. In place of 5x minus 3, I simply call it v. So this is now what? A product rule. Alright. So which means from the rule, keep u, differentiate v, plus keep v, differentiate u. So which means I have to differentiate u with respect to x. I also have to differentiate v with respect to x. Alright. So from u equals 3x squared plus 2. Alright, so I will differentiate u with respect to x, du dx. And from the formula method, I said that to differentiate such, simply use what? The power to multiply what? The variable itself. So I'll simply have 2 times, this is 3x, okay, then subtract 1 from the power, 2 minus 1, okay. This is now a constant. The derivative of every constant is simply what? 0. So I'll simply have plus 0 because there is no variable attached to 2, so it means 2 is a constant. So the derivative of 2 becomes 0. Alright, so du dx is now equal to, this simply gives me 2 times 3 is 6 to the power of x raised to the power of 2 minus 1 is simply what? 1. So this is du dx. Okay. Next is to find what? Dv dx. So from v equals 5x minus 3, I will simply have dv dx to be equal to, same thing for the formula method for differentiation. I said this x simply means x to the power of 1. I also said in that video that if you are to differentiate a function which has a number attached to the variable x, but x is simply raised to the power of 1, simply the derivative of that function is simply going to give us what? The variable, the number attached to it. So if I differentiate 5x, I will simply have what? 5. Okay, simply the number attached to what? X. Since x is raised to the power of 1, then the derivative simply becomes the number attached to what? X. But minus 3 here is a constant, and the derivative of a constant always is 0. So I can simply say minus 0, or I will see it. But that now implies that dv dx is simply now what? 5. So I have this for dv dx. okay? But from product rule of differentiation, I have y equals u dot v, which is what I have here now. dy dx, the rule simply says keep u constant. So I have u differentiate v, this is the v dx, plus now keep v constant, so I have v differentiate u with respect to x, so this is du dx, okay? So therefore dy dx is now equal to, so from the equation we said let u be 3x squared plus 2, okay? So in place of u we have 3x squared plus 2, then differentiate v with respect to x, so dv dx gave us 5 times 5, okay? Plus now keep v constant, and v is simply 5x minus 3, so we have 5x minus 3. Now differentiate what? U with respect to x, so du dx actually gave us 6x, so you have times 6x, okay? So that becomes your derivative. Now you may wish to expand the bracket, or you may wish to leave your answer like this, but let's expand the bracket and see. So this becomes 5 times 3x squared gives us 15x squared, okay? 5 times 2 gives us plus 10, okay? Plus 6x times 5x simply gives us 30x squared, okay? 6x times minus 3 gives us minus 18x, okay? So we can simply say that dy dx, is now equal to, okay, so we can now collect like terms. I have 15x squared there, I have 30x squared there. Let's bring them together. 15x squared plus 30x squared, okay, I have plus 10 and minus 18x, so minus 18x plus 10, okay? So dy dx is now equal to 15x squared plus 30x squared, simply gives us 45x squared, okay? Minus 18x plus 10, so that becomes the derivative of that function from product rule. Alright guys, I hope you enjoyed that video. I will see you in the next problem with another question on product rule of differentiation. In the meantime, if you're new to the channel, please don't forget to subscribe to the channel, and of course, like the video, share your thoughts in the comment section. I will see you in the next video. Thanks and cheers.